Let us take this JEE Advanced question. Let fx equal to, the function is given to us for x not equal to 1. This is the function for x not equal to 1. Now, two questions are asked. One question is limit extends to 1 plus fx. Limit extends to 1 plus fx. And another one is limit extends to 1 minus fx. These two questions are there in the four options. So first one, if you check, limit extends to 1 plus fx, that is x is tending to 1 from the right side of 1. That means x is more than 1. So if x is more than 1, you can easily see that when x tends to 1 plus, mod 1 minus x will be written as x minus 1 because x is more than 1, and as x tends to 1 minus, mod 1 minus x will be written as 1 minus x because x is less than 1. So let us first take limit extends to 1 plus. Limit extends to 1 plus. Let us first redefine this function. It will be 1 minus x into 1 plus x minus 1 divided by x minus 1 into cosine of 1 by 1 minus x. We need to find this limit value. So this is equal to limit x tends to 1 plus. In the numerator, if you see that 1 is getting cancelled, 1 minus x square divided by x minus 1, that is minus of 1 minus x into cosine of 1 by 1 minus x. So 1 minus x factor will be cancelled in the numerator and denominator, giving us 1 plus x factor. So it is limit x tends to 1 plus minus of 1 plus x into cosine of 1 by 1 minus x. Okay, so we have simplified to this particular form. Now, here you have to analyze that 1 plus x, as x tends to 1 plus x is tending to 2 plus. 1 plus x is tending to 2 plus. It is slightly more than 2. So, in the neighborhood of 2, it is more than 2. But what is happening to cos 1 by 1 minus x? This is of the form cos of infinity. This is cos of an angle which is tending to infinity. And since cos is a periodic function which oscillates between minus 1 and 1 continuously, periodically, so at infinity, we cannot say what is going to be the tendency of the function because it will continue to oscillate between minus 1 and 1 without any ending. So, cosine of an angle which is tending to infinity, because x tends to 1 plus means 1 by 1 minus x is tending to 0. 0 minus 1 minus x is tending to 0 minus 1 by 1 minus x is tending to minus infinity. Actually, cosine is an even function, so it doesn't matter. You can write it as plus infinity also. So, cos of the angle tends to infinity. We cannot say what is the limiting value because it will oscillate between minus 1 and 1. So, this is tending to 2 plus, but this is oscillating between, this quantity will oscillate between minus 1 to 1. So something tending to a non-zero finite value into something tending to something oscillating between two values minus 1 and 1. So this product has no tendency in the limiting sense. So we'll say that this limit does not exist. This limit does not exist. Okay, because the limiting value has no particular tendency to reach a particular value because the value is just oscillating, right? So this limit does not exist. So first option, so limit extends to 1 plus does not exist. Option D is correct and option C is false. Now let us analyze the other one, that is limit extends to 1 minus. What will happen for limit extends to 1 minus? Redefine the function. 1 minus x into 1 plus 1 minus x divided by 1 minus x. It will be 1 minus x mod value into cosine of 1 by 1 minus x. So if you simplify the numerator, you can see the numerator is 1 minus 2x plus x square. The numerator is 1 minus x square divided by 1 minus x into cosine of 1 by 1 minus x. So 1 factor 1 minus x cancels and that is giving us limit x tends to 1 minus 1 minus x into cosine of 1 by 1 minus x. Now see, this is an interesting form because as x tends to 1 minus, that is slightly to the left of 1, 1 minus x is tending to 0 plus. It is close to 0, slightly more than 0. So this is tending to 0 plus, and this value is still oscillating. This is cos of infinity. So this value is still oscillating between -1 and 1. This value is oscillating between -1 and 1, but it is getting multiplied with something which is tending to 0. So here we can apply Sandwich theorem, that is cosine of 1 by 1 minus x is oscillating between -1 and 1. So if I multiply 1 minus x here, which is a positive quantity in the neighborhood, then it will be sandwiched between plus 1 by x and minus 1 minus x, plus 1 minus x and minus 1 minus x. This function is sandwiched between minus 1 minus x and plus 1 minus x. And what is happening when limit extends to 1 minus? Limit extends to 1 minus this quantity 1 minus x, that is tending to 0 as extends to 1 minus, and minus of 1 minus x, that is also tending to 0 as extends to 1 minus, or 1 from the left side. So this side tends to 0, this side tends to 0, so the sandwich function must also tend to 0. So in this case the limit will exist and this limit value must be equal to 0. So option A is correct, B is false.